Okay, so this is lesson for day 16 in Algebra 2, radical expression operations. We're adding and subtracting radicals. We need to know how to do this. This should have been taught to you before, but this is probably new to a lot of you, unfortunately. So we're going to spend a day on this. This is just building on the stuff we already know, okay? So it's like when we add radicals together, we need to make sure they're like terms. So kind of like the big idea is like when you get a big, let's say someone give you a big thing of candy, like a big bag of candy, right? Halloween's coming up. All kinds, okay? But you don't like all of them. There's like some weird candy in there, and then there's like good, like your favorite candy, chocolate, whatever, right? Sometimes you might want to organize everything into different piles so you don't have to deal with certain candies, right? So, anyways, here are the steps. If you're in the video, you should pause it. Okay, so here's the big idea. Remember this from Algebra 1. Let's say we had 2x squared plus 3x minus x squared minus 6, or plus 6x. What would we do to combine like terms? Add what?
2x plus 3x. And then subtract x squared.
Okay, I'm hearing a lot of things. Let's work with the largest exponent first. 2x squared. 2x squared minus x squared is? Just x squared, right? And then 3x plus 6x is? 9x, right? Do you remember this from Algebra 1? Okay, here's the concept. I want you to understand the concept when we're working in math now. Okay, we always combine the same base and exponent together, okay? Do you see how this is x squared? We combine it with this x squared, right? Good. And then this is x to what power? X to the first, x to the first. Do you see that? Okay, so now I'm gonna add it now to what we've been learning. Eyes up here. Eyes up here. Okay, so we got 3x to the 1/2 plus 2x to the 1/3 minus 2x to the 1/2 plus 4x to the 1/3. Okay? Don't get freaked out. All you're doing is getting the same base and the same exponent together. Okay? X to the 1/2. So there's 3x to the 1/2. Are there any other places where there's 3x to the 1/2? Or I mean x to the 1/2? Yeah. What's 3x to the 1/2 minus 2 of them?
There's just one x to the 1/2.
That's right, just one. Do y'all see that? Okay, then we got x to the 1/3. There's 2x to the 1/3 here, plus 4x to the 1/3. How many is that?
2x to the 1/3.
Okay, again, what's 2 plus 4? Okay, good. I heard someone say 2. Okay, so 2x to the 1/3. Okay? Does that make sense? Okay, we're almost done. Eyes up here on this concept. Now remember last week, couldn't I rewrite, look at this second line right here. Couldn't I rewrite 3x to 1/2? How would I write this as a radical? How would I write just this as a radical? No. How do you write this as a radical, everyone? Second root of. Wow, you kids forgot.
2, I can like draw it in the air.
No, you start with 3. There's a 3 out in the front, so your rewrite is 3 square root of x, right? Do you all see that? Isn't this the same thing as 3 square root of x? Is there a parenthesis around the 3? No, so we make that as a radical? No. Let's keep going here. How do I write the next one? Plus 2 cube root of x, right? Do you see that? Okay, 2x to the 1/3 is like saying 2 cube root of x, right? Do you see that? Or minus 2x to the 1/2 is minus 2 square root of x. Do you see? Yes? Okay. 4x to the 1/3 is saying 4 cube root of x. Does that make sense? Okay. This is the same thing as that, right? Do you agree that this is the same as that? So shouldn't I have the same answer as there? Okay, let's look at this. Let's combine like radicals. What's 3 square root of x plus, or 3 square root of x minus 2 square root of x?
1 square root of x.
Good, just square root of x or 1 square root of x. Good. You could put a 1 here, but it's redundant. Okay, we don't have to put a 1 because we already know there's a 1 there. It's like 1 of anything is itself. Okay? 2 cube root of x plus 4 cube root of x is
6 cube root of x.
6 cube root of x. Okay, so I got a question for you. Isn't this the same answer as that answer right there? Isn't this the same thing? X to the 1/2 is the square root of x. Y'all see that?
Exactly, you just need to change it into that.
Or 6 x to the 1/3 is 6 times cube root of x, right? Makes sense? These? I made them up. This is the original problem because I want you to see the. This has nothing to do with this.
Oh, okay.
Okay, that's why we have to focus because I'll say, let's try this new one, okay? We want to make sure we're focusing.
To get 6 radical x, or 6 cubed radical x, what you do? You multiply 3 to 2.
I didn't multiply anything there, I just added them. Couple of these, that's the basic idea. Here's numbers 1 and 2 you're just watching right now. Eyes up here, eyes up on the board, and I'll show you how to do these. Okay, so number 1. Okay, we got -3 rad 3 minus rad 3 minus 2 rad 3 minus 3 rad 5. I'm noticing that a lot of these have the same square root sign, right? I combine them. So I think, what's -3 minus 1, right? Isn't there an imaginary 1 right here? So it's like -1 minus 2. Okay, what's -3 rad 3? Or what's -3 minus 1 minus 2? Negative. Good, so it's -6, right? We're going to keep this 3 to the 1/2 power. What did I write here? Oh, I keep.
Where'd the 6 go?
-6, right? Do you see? We have each of these becomes -6 to the square root power, right? Then we take the last one. Is the square root of 5 the same thing as the square root of 3? No, so can I combine that in there? No, so we just bring it down like it was another term and then we're done. That's how you do number 1. That's it.
I thought you couldn't have negative.
Yeah, you can. On the outside you can. Okay, stay there. Don't write anything. Okay? So we're combining radicals, right? Did you see how I combined? So again, what did I just do? I looked for common radicals. So you see how this is rad 3, square root of 3, square root of 3? We just add the coefficients. What's -3? -1. Pencils down right now. Pencils down. -1. -2. -6 rad 3. You see? And then we got -3 rad 5. We bring that down. Make sense? Okay, good. Next one, number 2. We got 3 cube root of 4 minus 3 cube root of 32 minus 3 cube root of -108. This one's a little scarier, right? Do we have any common radicals here? No. So now I need to see if I could simplify these before combining them. Square root of, or cube root of 4. Is there anything I could make this? Braden, look up here, bud. I need you guys looking up here. Can I simplify this at all? Is there a cube root of 4?
Yeah, it's 2.
No, that's the square root of 4, bud. Is there a cube root of 4? No. Okay, good. So we're going to leave that alone. Let's look at this one. Is there anything I could simplify with 32? Yeah, I can. If I do a factor tree of 32 on the side, look over there. It becomes 2 times 16. And then we got 16 becomes 4 times 4. Or it's like 2 times 2. Oh, man. My bad. Don't worry about that. Got it. Right? It's 2 to the what power? 2 times 2 times 2 times 2 times 2, right? 2 to the what power? 5th power, right? So I could rewrite this as 2 to the 5th, or I know that it's a cube root. I could say that this is like saying, I'm gonna bring the first part. We didn't change that, but the second one here, I could say that this is like the cube root of 2 to the 3rd times 2 squared, right? Isn't that the same thing as 2 to the 5th?
Yeah.
Good, okay? This is stuff we did on the test. Next one, we got -3 cube root of -108. Now, I'm noticing that 2 squared is going to become 4. This is going to become a 4. But this is, how do I get this to be positive? So I'm going to do another factor tree on the side. I'm going to do -108. I know this is like saying 4 times 27, which is like 2 times 2 times 3 times 9, or 3 times 3, right? So isn't 108, look up here, isn't 108 the same thing as saying 2 squared times negative 3 to the third power? Do y'all see that? Okay, so it's kind of like a puzzle. You have to get it out, get the numbers out so that the insides will all be 4. Because I know that 2 squared is going to be 4, and then 2 squared is going to be 4 here. Okay, so now I'm going to simplify. Watch up here. So I'm going to bring down the first part. I can't do anything with that. What can I take out of the second term? 2 cubed, right? What's 2 times negative 3? Negative 6. Good. What? And then we're going to bring down the rest, which 2 squared is going to be 4, right? Y'all see that? Next term, what can you pull out of the last term? What? Negative 3. So we have negative 3. What's negative 3 times negative 3, everyone?
Positive 9.
Positive 9, right? So we got positive 9. And then what's 2 squared, everyone?
4.
So we got the cube root of 4. Make sense? Good. Now we can combine like terms. What's 3 minus 6 plus 9? Okay, what's 3 minus 6? Negative 3 plus 9? Positive 6. Good. That's your answer. Okay? That's going to be a harder one that you would have to do. Any questions on numbers 1 or 2? Okay, so let's start with ones. Ones, tell the group how you did. Tell your group how you did number 1, and then let's have threes go second. Threes are going to tell the rest of the group about number 2. Ready, set, and go. Let's do number. Sorry about that. Okay, number 3. Number 3, let's write this down. 3 rad 5 plus 2 rad 3 plus 3 rad 3 plus 3 rad 5. Okay, so looking up here, turn to your neighbors and identify any common roots that you could combine before you start. What are the common roots we could combine, everyone?
3 and 5.
Good, 3 and 5. So we got square root of 5. Let's focus on those first. What's square root of 3 plus, what's 3 rad 5 plus 3 rad 5, everyone?
6 rad 5.
Good, 6 rad 5. Excellent. Okay, finish up my problem and show me on your whiteboards what the final answer is. Okay, answers up. Answers up. Some of your answers are a little off. Don't erase your boards. Okay, everyone's checking their work in the front. You should have 6 rad 5 plus 5 rad 3. If you got it wrong, please identify where you made a mistake.
Don't erase it.
Okay, thank you. Okay, so that's number 3. Okay, did y'all talk about it?
Yeah.
Okay, cool. All right, number. Yes, thank you for asking. You could also erase this little windshield wiper button on the top right. It erases all the strokes. Okay, it's kind of cool. All right, number 4. Number 4. So it looks a little harder, but I know we could do it. We got 3 cube root of 6 plus 3 cube root of 4 minus cube root of negative 6. Okay? Before we start, what do you notice there's a problem with on one of these terms?
Negative.
Which one?
6.
Good. I got a question for you. Let me show you a little trick, actually. When you have a negative 6 and there's an odd index, look up here. Isn't a negative 6 the same thing as saying, like, negative to the third power? Right? What's negative times negative times negative?
That's going to be positive.
Negative. Good. Thank you. That's okay. I like your zealousness, but yeah, your zeal actually. Okay, so it's negative, right, to the third power. So can I take a negative sign out? Yeah, so what's a negative times a negative on the outside? Positive, so we could take that negative times a negative. It's going to become a positive. Okay? So I'm going to bring the rest of the problem down so you can see what's happening, or what has happened. Finish up the problem for me, okay? Are you confused? Well, since there's a cube root of something, we could change this negative to a negative to the third power, right? You got a brain fart?
Yeah. I don't know if I should let it go or not.
I think when you have it, it's already gone.
No, I'm holding it in.
That's never good. Yeah. That's polite of you, though.
Thank you. Being a gentleman.
What's one of anything?
Well,
So, yeah, it's redundant. Okay, good. I don't know yet. I don't want to tell you.
maybe I should feel
Look at this one carefully. This is. Don't overthink it.
I'm overthinking.
What's 3 minus 3, everyone?
3 minus 3 is 0.
Okay, so it's equal to 1. I'm noticing some people are saying 1 or writing 1. Again, 3 minus 3 is equal to 1? No. Okay, another 20 seconds. What's 3 minus 3?
Is it going to be this? It could be. Could be.
Okay, answers up.
I could be right, but I could be wrong.
3 minus 3 is 1. That's what you're saying right.
Oh, dude, I think I was right, dude. No way, dude. Look at the bank.
Okay. Eyes up here. Again, eyes up here, look what happened. What's 3 rad? Eyes up here, you guys see your answer is 3 rad 6 plus blank rad 6. Or 3 rad 6. Good. So 3 cube root of 6 plus cube root of 6 is 4 cube root of 6. Y'all see that? Do y'all agree?
Yep.
Good. What's 3 cube root of 4 minus 3 cube root of 4?
0.
0 cube root of 4. What's 0 times this?
0.
Okay, so what's this plus 0? It's just this. That's your answer. Y'all see that? Okay, so if you made a mistake, please show your group where you made a mistake.
Adding 3 cube root of 6. It should have been 4.
Here we go, continuing on number 5. Now number 5, you think it looks a little crazy. Can we combine? Turn your neighbors and tell them what you would combine on number 5. Good. What's 3 rad 54 plus 2 rad 54? Okay, good. So I got a question. Think about a strategy to yourself for 10 seconds. Is there a connection between square root of 54 and square root of 6?
I'll have to find out.
Talk to your group really quick. Make a strategy. Okay. I'll give you about a minute to finish this problem. There's still some things you could do. So number 5 is up there. We're done with that. Number 6. Number 6, I accidentally copied number 2's problem here, but it's supposed to be different. So instead, let's make these positive signs. This is exactly like number 2, but use number 2 to help you break it down, okay? Go. And this first one I can't really do anything with, so I'm just going to bring that down. Put a plus sign there. Negative 108 is just like saying negative 3 to the third times 2 squared. Yes? Okay, let's simplify this. I'm going to bring down this first term. I can take out 2. 2 times 3 is? 5. 2 times 3 is? 6, right? Yes? What's negative 3? I'm going to bring out negative 3 now. What's negative 3 times 3?
Negative 3 times 3 is going to be negative 9.
Negative 9. Oh, okay.
Oh, no, I didn't.
What's all of that combined? Some of you got 0, right? Don't erase your boards. You're supposed to talk about where you made a mistake. Don't erase your boards.
You're coming wrong. I can put it down. You almost erased it.
Okay. So that concludes